Howdy, Arkansas. How we doing? Okay, I know I'm cutting into your happy hour, so we're going to make this fun, I hope, and thank you so much for coming. I know a lot of you have come a long way, and that's really great, and it's wonderful to celebrate Darwin, who was a person that affected probably about as much of our lives as Lincoln did, when you come to think about it. As I said, they're born on the same day, which is pretty cool. I want to talk to you a little bit about this stuff. Can you all see the slides okay? Are the lights so cute? They good? Well, you know, you complain if you got a problem. I've seen this before. I know how it comes out. There's the man himself. This is the saintly Darwin, you know, picture him very old age. But we seldom stop to think that when Darwin made his great discoveries, he was really not even 30. And that's kind of an interesting thing to think about. I'm over the hill. I know some of you feel you are too. The future is in good hands. Don't worry about it. I want to talk a little bit about words, education, how we teach things. Etymology really is important. And those of you who've read The Origin of Species, if I asked you how many times does Darwin use the word evolution in The Origin of Species, what would you tell me? None. He uses the word evolved. It's the last word of the book. That's the only time he uses it, and he does it because it meant something different in his day. It meant something that was already predetermined, like you know how a leaf or a fiddlehead fern unrolls or a caterpillar turns into. That was him is evolution. It was more of a developmental thing. But after The Origin of Species, people came to use evolution the way we use it now, which was interesting. He used the word transmutation instead, which is a change from one kind of species into another in a lineage, something like this, any kind of transmutation, however that works. His own definition of evolution is simple, and it's probably still the best one. Descent with modification is just fine, because it's about generations and generations and generations and variations passed on, being variably successful or not successful. That's really what it comes down to. And that was what he was trying to convey. It's a very simple, and it encompasses those patterns, those histories, those processes, even things he didn't know about, like molecular genetics. That's all part of this. He just didn't know it, but it's a nice definition. Sometimes the simple things are just fine. You'll sometimes see this alternate definition of evolution, and this is used by some scientists as well as by other people, but it's a very kind of a narrow definition, and I kind of like to explain a little bit about that later. One of the main things about this is that this word here, which a lot of people are afraid of, and because it seems like a funny word. Now, I know that everybody under the age of about 35 is sitting there going, well, I don't know, looks okay with me. But you are the same people who will say to people of my age, oh, Dad, like that's so random. You get that a lot? Can I have some hands on this? Oh, come on. I know you get this. And the randomness part, that's okay. You know, it's just a different way of using the word, but it's like something came out of nowhere, right? There was no connection between here and there. It just happens. But that's not what scientists mean. Like evolution, we use different words. That's not what scientists mean at all when we talk about random. We mean something quite different from this. Let me talk about, we're talking more about the distribution of something than its cause. The internet being a wonderful thing. You can find factoids everywhere. Here's one. There's the average household fires per year in Riverside. So that's 0.05% of the population. Okay, good? So that would mean probably that if you lived in Riverside, the probability it would burn would be about 0.05%, right? If the causes of fire were random. But we know the causes of fire are not random. There are three main causes of fire: smoking in bed, kicking over the lava lamp when you're stoned, and ex-wife gets the house, ex-husband comes back and tortures it. These are not random with respect to cause. They happen. Fires don't just spontaneously ignite. If we knew in advance which house was going to burn, our fire departments would have things a lot easier. They just come and wait for the fire. Okay, we'll put that out. That was easy. And insurance companies. We wouldn't need insurance companies. We'd already know. That would be good. So random as cause is not really important in science. It's mostly the distribution of effects. When we know what can happen, we know that a duck's head is not going to pop up on a trout. That's not what we're talking about. So we know these kinds of things a little bit better. Mostly when we talk about random in science, we're talking about distribution of effects in the population of causes we already know. If you think about genetic diseases, if you think about the probability of doing anything, the possibility of, how many of each kind of flower color you're going to get in a generation, this is all statistically variable according to processes we understand. But that distribution of outcomes is what we call randomness. That's our best statistical explanation of this. So randomness really is connected to causation, but in a funny way. So that's our random part. And I say this because a lot of people are scared about the notion of random in evolution and other parts of science because they think it means there's no rules, nothing goes on here, anything can happen, everything, there's no way we can talk about direction or cause. And I think that the idea of evolution being unguided is exactly the opposite of what Darwin was talking about, because what's Darwin's fundamental idea? Natural selection. Now, I tell my students at Berkeley, are you here because you were selected or because you're here at random? Sometimes it's hard to tell. But the same is true for the faculty. So, you will find formulations of evolution that look like this. And it's not, sometimes a scientist will put it like this because random variation is important. Well, it's not random in its cause, it's random in its distribution. And natural selection, those are important components of evolution, but it's not the whole thing. But you have people like Cardinal Schönborn, who is getting his scripts from the Discovery Institute in Seattle, who bring you intelligent design, who are telling you that this is the deal. So there are lots of other things that are involved in evolution. It's kind of like defining a house as the plumbing and the front door. Those are important components, but we have a lot of other things as well. Darwin himself had the typical Enlightenment views of the 18th century that he grew up with and that our founding fathers grew up with. This is his view. He says this in his writings. He thinks there is a first cause, and by a first cause, he means that there is some higher power. He is a deist. He does not necessarily personify the idea of God. Our founding fathers were mostly the same. They don't see a big guy walking around in sandals in a garden somewhere. They're looking at some kind of force. It's a moral force, it's an ethical force, it's a creative force that's in the universe. This is very much in keeping with basic Enlightenment thinking. And Darwin thinks this is what's out there. And I tell people that that's what he thought. So if you agree with him, then you're a Darwinian, I think. Make sense? Yeah, okay. Passages like this in The Origin, this is not Victorian purple prose. He means it. It should be read straight. He's trying to tell you that nature is not evil. It's not moral. We don't put these views on it. This is just what organisms need to do in order to survive. That's the business of living. And this is what he's trying to tell you. So, don't despair. Don't, he really thinks it's fine. It ought to work out. He is what we would call a meliorist in a way that he thinks that things should get better. He wants society to get better. That's what he spent a lot of his life and his private life doing. So in order to go just a little bit farther on this, I have kind of a spectrum of different kinds of views about theology and religion. And one of the first things to point out is that there are three things there that are normally classified as atheists. An anti-theist who thinks he's absolutely convinced there are no gods and and he's adamant about it and happy to argue with anybody on the point. But then I think you have non-theists, people who just don't have any particular truck with the concept. They run their lives without it. It just doesn't enter into their thinking. Allotheist is a word I coined. Allo means different. Those of you who are dinosaur buffs will know about Allosaurus. That was made as different reptile because it was different from the one that... So, and an allotheist is someone who believes in God, but just different gods than somebody else believes in. And they don't accept his God, so they call him an atheist. And that's been common ever since the Greeks. So So that is, all these kinds of people and others are classified as atheists by some people. Then we have agnostics, a term coined by Thomas Henry Huxley. Then we have deists, which is what Darwin and the founding fathers really are. And then theists, people who see a personified God. And then I think fundamentalist people who, in our common parlance, do not have use for anything that is not part of very strict scripture. Now, you can have fundamentalist atheists, too. And they are exactly the opposite. They have no use for anything that's in Scripture. You can have fundamentalist Zionists, you can have fundamentalist, pretty much anything. It's not confined to any particular sect. It's just people who are intolerant of any other way of looking at things. And people who are theistic evolutionists, those who think that evolution happened but God guided it, would probably belong in the concept of theists, people who understand and personify a God and work that way. But that's just a partial spectrum of things. But as I mentioned, Darwin and Jefferson and people like that are mostly considered deists, if you have to categorize them at all, and they're not exactly identical. Now, what do we think about evolution in this country? Well, for about 30 years, the Gallup organization has been running polls, and they ask questions, and they get pretty much the same percentage of answers throughout all these years, if you've been following, and we have. Which of these statements best reflects your view on things, they are asked, and those are the results at the bottom. Now, humans evolved with God guiding, that's your theistic evolutionists people, and that's, a good chunk. Humans evolved, God no part, those are your atheists. God created humans in their present form. This is nearly half the people. Now, I know that some people would be inclined to look at this group as made up of people who think that the Flintstones is a documentary. I don't read it that way. I think this is a very carefully nuanced view, and it encompasses a lot of things because survey questions are hard to answer and they're hard to devise. For example, if you happen to be of a persuasion where you think that animals and everything was evolving just fine, but maybe 10,000 years ago, numbers don't count, that God breathed a soul into humans, you might answer the third one. And this is the problem with polls. I'd have a lot of sympathy for that third one. I think there's a lot of people out there who would. And this is complicated, this whole poll is complicated by the fact that George Gallup was a conservative Christian who saw his mission on earth to have a polling operation to understand God's will for his people. Now, that may lead you to ask questions in a certain way. But every way you ask a question is going to be different. People from the American Way is more of a liberal group on the spectrum. They asked a question in a more recent survey. In this way, they phrase it completely differently. Is the scientific theory of evolution compatible with a belief in God? Survey says, okay. So they asked some other questions of the same people. And what they found is that when they asked other questions of people, they got these answers. So a question you might ask is, well, who are the people that have all these views in common? And they are conservative or fundamentalist or evangelical Christians who were primarily among the people asked, who felt that way. Coincidence or correlation? Well, it's not a coincidence. It's not random. These views are correlated in the people that answer the questions. So we know it's all part of a socio-political, philosophical spectrum. Fine. Okay. So we know where we are. Now, about in the early 90s, this new idea came on the scene where people asked, is it okay to teach intelligent design in the schools? And that was kind of a naughty question because intelligent design was kind of new on the block at that point. Okay, the guy is a national treasure. But that's not what intelligent design means. They're not trying, we have to be fair, they're not trying to say that everything is ideally designed and constructed in nature. An original formulation of intelligent design goes back to the 1700s and even earlier, and it was put into very articulate form in the late 1700s by the Reverend William Paley in England. And Paley begins his book by talking about if you were walking along a heath and you stubbed your foot against a stone, you wouldn't think anything of it. The stone could have been there forever. But if you encountered a watch, you wouldn't draw the same conclusion. You would see that the watch is very intricately constructed. It has a function. It has many working parts. If you took some of those parts out, the thing wouldn't work anymore. And you would conclude necessarily that someone had put that watch together. They had designed this watch. And then Paley, who did know a lot about natural history, went through a whole catalog of all the intricate adaptations and co-evolved. We didn't say co-evolved, but things where organisms are kind of adapted to working with each other, and said, with all these intricate relationships to each other, could you really say that the world, like your watch, did not have a designer? So just as a watch implies a watchmaker, the intricate construction of nature implies a creator. This was a very popular argument. Darwin was very impressed by its rhetoric, and he used it, by the way, in The Origin of Species, arguing from artificial selection up to natural selection. So he kind of turned the tables on Paley eventually. So that's the original formulation of this. And there's some difficulties with that, because if you look at humans, we can pray, we can do good works, we can think we lead good lives, but bad stuff happens to us. And, so does this always mean that everything is going to work out fine? These are not scientific questions. These are philosophical and religious questions, but they are on the minds of people when we talk about intelligent design. I want to say that intelligent design is not theistic evolution, which presupposes that God makes the universe and pretty much lets it run with natural processes that we can study, but rather intelligent design is something different. The intelligent designers of today, particularly, say that yes, the design of the universe implies a creator. They're fine with most of science, but sometimes there are some very complex parts that they don't see any way you could arrive at this naturally, by piece assembly. Therefore, they conclude that's where you have to suspend natural laws. That's where the designer comes in. That is intelligent design. So in science education, we call that a science stopper, because you can't study miracles. And this viewpoint about the modern version of intelligent design, put forth mostly by people from the Discovery Institute in Seattle, became sort of the central focus of a campaign to try to get intelligent design taught in schools and promulgated in many public arenas. I want to talk about the science of this. It kind of gets to this thing I was mentioning just a minute ago about irreducible complexity. If you can find a feature that is so complexly engineered that you can't see how it could have assembled itself from fewer parts and more simpler functions, then you must conclude that it was made by a designer, an intelligence with a power greater than ours. And Mike Behe at Lehigh is the main proponent of this. And the poster child for this is the Bacterial Flagellum, which is a little kind of whirly thing on the back of one of these little, things that runs around and just bacterializes all day. And Mike's argument is that the flagellum, little tail part, which goes around and around, has 50 working parts. He says if you take away any of them, it won't work. And therefore, you can't figure out a way that this could have been put together. But as it came out in the trial explained by Ken Miller and other people, there are some flagellas that have many fewer parts than this and still function perfectly well. Not only that, if you go and find bacteria who have flagella with even fewer parts, it doesn't work as a little rotor anymore, but it does function as part of the immune system. So it is entirely possible to reverse engineer this and accept that you have, in fact, originally bacteria with flagella that serve the immune purpose, but that at some point it becomes a propeller thing, and that this is another focus for natural selection. This is the way it has worked in every kind of organism that we look at, and the question is whether bacterial phylogenies will support one interpretation or another when they're finally worked out. The main problem, though, is that Mike Behe and like other other intelligent design people and creationists in general do not accept the basic principle in evolution we call exaptation. And exaptation is where you have a structure that's used for one function, and then it acquires a second function. You can think of many things that you do with parts of your body. They're not just one thing. And these things have evolved through time. Sometimes this whole secondary function evolves that makes it almost lose the first function. Sometimes you have 2 or 3 functions. A really good example is the feathers of birds, which were first simple and hair-like even before dinosaurs were birds. These were insulation. They had color patterns, so they were used for different things. They got larger, these feathers, and on the hands, we find nests of dinosaurs where they're using their hands in a position where the feathers would shelter the eggs while they're brooding. And then one lineage of these gets really big feathers, and they start getting aerodynamic. And then we have these little things in the trees today. And so this exaptation is a change in function. It's the same structure, but the structures become elaborated. They acquire different functions. But it's the same basic function. So that was our whole problem there. In general, microevolution, like little changes in populations, are not a problem for people like this, but they don't like big changes. They don't like major groups evolving from other major groups, created kinds in the language of some people. And the complex packages, these complex adaptations that are so interesting, at least to me, cannot evolve through natural means, but they require a designer. Now, this is the cover of the book Of Pandas and People, which is a text developed by intelligent design advocates. And this is a page showing their concept of the giraffe and how the very complex features of the giraffe are so different from everything else, it seems impossible to have evolved them through natural means. Of course, all you'd have to do is look at an okapi, which is a short-necked giraffe, and you could see that the giraffe did not suddenly spring full-blown. Its ancestors had shorter necks, more like other kinds of critters. Well, the panda there on the front looks very sad. I think it's because he knows what's in the book. And I want to talk about this more later when I tell you a bit more about the Dover trial. This is an image in the trial, in the pandas book, that is a comparison drawing of 2 kinds of animals that seem to bridge the transition from water to land. That's a fairly standard thing. Now, you'll notice that the version below was developed by my graduate student, Brian Swartz. We call it an evogram, and it's a bit more complex. Brian developed the evogram because he thought people should see more of the evidence that we have. So on the top row, he's got you pictures of the fossils. In the second row, it's color-coded to see how the parts correspond from one to the other, and so you can see how they change more easily. Then the third row is the relationships of those guys according to a phylogenetic analysis. And underneath there, you see reconstructions of what we think they looked like in life, more or less. So that gives you an idea of what the science is behind this, as much as we can do it. To explain this diagram to you would take half an hour. Glancing at it for 30 seconds gives you an idea that we have evidence for this and that this is the way we think about things. The top illustration offers you a comparison, but it invites you to draw contrasts as much as similarities. And that's what a two-way comparison always does. The one on the bottom uses a bunch of forms, and we think that's more in keeping with what we understand and how we understand that things have changed through time. I want to use one extended example from pandas, and this is their statement about the origin of whales. By and large, Darwinists believe, I like that whales evolved from a land mammal. There are no clear transitional fossils linking them to whales. If whales did have land-dwelling ancestors, it's reasonable to expect to find some transitional fossils. Okay, fine. I would like to show you what we know about the origin of whales, a little bit more. Here I'm going to start with some Eocene Artiodactyls. Artiodactyls are hoofed animals. It's all our hoofed guys except the horse, the tapir, and the rhino. All the other guys who have hoofs are Artiodactyls. They've been known since the Eocene 50-something million years ago. The exact number doesn't matter, but they look something like this. The closest things to whales today are hippos. We love hippos, right? And you wouldn't know what to think about it. And it was, the evidence was kind of funny for a while, but their molecules are what convinced us. They have molecular sequences, hippos do, that are only also found in whales, which really freaked us out. But, it's looking pretty good. The fossil whales themselves, here's Pakistan, these are from the Eocene of Pakistan, and that is a skull, or part of a skull, of one of the earliest fossil whales. What tells us it's a whale is the way the ear bones are structured. Whales have ear bones that are unlike other kinds of mammals, and we find critters in the Eocene that have whale-like ear bones, but they look like this. These are not swimming, they might be swimming, but they're not, they don't look like Moby Dick. These are walking animals, quite obviously. And where did they live? Well, the interesting thing about this is when you do the isotopes on their bones to look at where they're getting the oxygen in their bones, the carbon, things like that, these isotopic analyses are coming out to be the same as source water coming from mostly marine sediments. So these guys seem to have already been spending an awful lot of time in the ocean, even though they are capable, perfectly capable of going around on land. So what happens is that it seems like they're doing this stuff before they get the whale-like adaptations and committing to that way of life, which is the way we think evolution works in general. These guys here, notice this next ambulocetus, which means walking whale. It's still walking. It's got these big paddle-like hands. Other than that, it looks pretty much like the other guys. It still can walk on land. Going a little farther down the line, the protocetids, these are guys who have their hips decoupled from their backbones. So they have much more flexibility in their spines. And you may notice that whales swim like this, not like that. And this is because they come from land animals, where as mammals, our posture and gait are set up like this. Our backs move more up and down as we go. Watch a cheetah or a dog running, they really get their back into it. When whales went back to the ocean, they did not return to swimming like a fish. They swim like this, which is another example of the terrestrial heritage. They also have these funny little ankle bones down there on the bottom. You can see a kind of little double pulley joint and then that big hooky thing that comes up off it. That's the heel bone, but I like to call them hooky things because they're mammal. I know. And that's an important feature because that little hooky thing and the double pulley joint is what are found in Artiodactyls that live on land. And we still find these in these early fossil whales. Also, their nostrils begin to migrate backwards along the skull, but they still have these ankles that are like an artiodactyl. Even in the basilosaurids, which are very long guys with very regressed nostrils, very long skeletons, very reduced hind limbs, as you can see there, you'll notice that coming off that little central bone there is a double pulley joint, and there's that little hooky thing coming off it. That's the same artiodactyl ankle you've seen all along, but I can guarantee you that thing had its ankle entirely, its whole limb entirely inside its body. It was not walking with that. It's showing you the vestige of where it's been evolutionarily. And today, we have almost a total loss of hind limbs. Occasionally, you'll see some bones in some whales today, but mostly it's gone. These are transitional things, and so with intelligent design, I have a concern that if we taught kids that you can't get from A to B, you can't make a transition from this group of animals to another, that you can't find intermediates in this way, I would be concerned that some point along the line we would find evidence for this, as we've done in so many cases. And then what are kids supposed to think? I'm not sure that's really good pedagogy. And so this is one of the reasons why I think if you try to limit what science can say about the natural world, if you tell kids there's no way to get from A to B, I don't know how you'd know that. I mean, logically it's tough as a proposition, but empirically it can get even harder. So these are problems with intelligent design that make us uncomfortable with putting it in any kind of science curriculum or treating it as science. The important thing, the third one, is something we haven't talked about yet, but scientists, there's no papal council in science. The way science gets accepted is by submitting your results to scientific journals, and those editors circulate your manuscripts to people whose identity you don't choose and you don't know, and they write down, what they think your paper does, what it succeeds at, what it doesn't succeed at. And you do not get published unless they think the science in it is sound enough to proceed. They don't necessarily have to agree with all your conclusions, but they have to say at least that you're following the best scholarship that we have to date. That's the way the whole field works. It's not perfect, but it's the best thing we have. I'm not a theologian, but on the other hand, most of the people who criticize evolution are not scientists. So I'm just going to walk a little bit farther here because these are problems that my own students have come up with. Some problems I think you might want to think about, just theologically, is the question of the imperfection of creation. That would be a problem for a lot of religious people. And ID says that, the creator has to come back in and fix some stuff he didn't do right. I don't know what it is. Most post-Renaissance theology downplays the divine intervention stuff. Science, as a function of the Enlightenment, spent a long time trying to get miracles out of common consideration in explaining natural phenomena so that we could actually study things. I hate the idea of science testing religious ideas. I think they should be separate in those respects. It's not the domain of science to criticize those things. And this question of theodicy is one that's been asked for thousands of years. The Discovery Institute folks say that they're working on it. Great. I'm so relieved. But this is a real problem, and from that, many students go immediately to this one: what good is prayer? These are not questions that you want to intertwine with natural events, processes, phenomena. I don't think science teachers and scientists should get into this business. If I were a theologian, I'd have enough trouble with it. So I think we want to keep these things out. If you want to get more into the nuts and bolts of intelligent design, you have to ask who the designer is. Because if you just say, well, it's just somebody out, well, I don't know. Well, they don't like to answer these questions, which is why we like to ask them. They don't like that answer. Like Bigfoot, Yeti, Kim Kardashian. They really hate this, because this goes to pantheism. Some of our guys say, well, why can't you have like one god to do the earth, another god to do the animals? And no. So, okay. Somehow they're not going to be real happy with those things. It's really this. They're really looking at the God of the Old Testament. Their writings, the Discovery Institute people, are very much focused on logos, John's Gospel, and those sorts of things. In fact, this is from their mission statement. Design theory promises to reverse the stifling dominance of the materialist worldview and to replace it with a science consonant with Christian and theistic convictions. Now, it's okay to have that idea if that's what you want, although, I kind of think church and state should be separate. But I wonder how you're going to carve up this pie. I want to know whose Christian and theistic convictions are we talking about? Who gets to decide who a Christian is? Who gets to decide what kind of a Christian government we have, if you're going to take it that far? So what you have to understand is that the Discovery Institute is not just stopping with science. They want nothing less than a complete overturning of our American institutions. These are their words, not anyone else's. And just for you guys who are philosophical junkies, naturalism, just the idea of how you study the natural world, there are two different ways to look at it. One is you can say that the material world is all there is. There can't be anything else. And this would be your kind of standard anti-theist view. You're not just working with no theist, you're saying, no, definitely there isn't any. But in science, we work by methodological naturalism, which says, we don't know what else may be out there. There are lots of other kinds of questions, like, whether you like, Bach better than Beethoven, or whether you prefer Rubens to Vermeer, or whatever. We don't know about that. White people, we have no idea why people do the things they do. watch reality TV. I don't know. But all we can do is think about what happens in the natural world. That's our business, and we just suspend everything else. And so people from all walks of life, all cultures and creeds and political and religious persuasions from around the world can work together in the field at the lab tables on this basis. And that's really important to us. We would never want to get rid of that. So what about the trial? Well, the trial began when a couple of members of the Dover, Pennsylvania school board decided that they really didn't want evolution taught in the schools. They looked at the book they had, which is a standard textbook by Ken Miller and Joe Levine, best-selling textbook in the United States, and they said, this is laced with Darwinism. Those were their words. I was like, okay, well, what's that? And they decided, thanks to propaganda from the Discovery, I shouldn't say propaganda, but I mean, the Discovery Institute was trying to get this stuff into schools and telling them that evolution was wrong, there should be another viewpoint. Okay, but and telling this was scientific, which, because it had never had peer review, that was a problem for some of us. So the school board told the teachers, we're going to use the Pandas book instead of that book. The teacher said, no, we're not doing that. That's a lousy book. The book we have is fine. We're going to use that. I said, well, okay, then we're going to give every kid a copy of this. I said, no, we're not going to do that. We're not going to use it. Or we'll put the books in your classroom so that students can refer to it if they want to. I said, we will not have this book in our classrooms. I mean, the courage of these teachers was unbelievable. They are the heroes. So the school district said, okay, well then when you come to the evolution part, you will read a statement that basically says evolution is just one idea and there's lots of other ideas out there like intelligent design. You should talk about it with your parents and clergy. And they said, we're not doing that. We're not going to do that. That would be against our professional ethics. So the school board said, okay, then we're going to have an administrator come in and read the statement. And he's going to read it, and he's going to leave, and there will be no questions afterwards and no discussion. I know, every teacher in the room is going, this is really model pedagogy. So they got the evolution unit, the administrator came in, read the statement, and a bunch of parents sued the next day. And they knew this was going to happen. Putting a trial like this together was kind of a big deal because you had to mount a pretty good a case for why you should do this. Vic Walczak from the Pittsburgh ACLU was flanked by Steve Harvey and Eric Rothschild, two guys from Pepper Hamilton in Philadelphia. We had a bunch of other lawyers. They were great people. But the scientific assembly of the case came from our nonprofit because the NCSC is the best place in the world, tracking this, knowing these people, knowing what the arguments are, and knowing what the trial had to settle. Because, as I mentioned, the school board would have easily, the plaintiffs and the lawyers would happily have settled for just 1 point, but we needed 3, and I'm going to show you what they are later. Anyway, NCSC members in the audience, thank you, thank you, thank you. The rest of you who are teachers, please join. Scientists, please join, so you don't have to do it yourself. Here's Mike Behe on trial. I just want to say this is from the judge's opinion. When Eric Rothschild put this big stack of books and papers on the witness stand and asked Mike, what about the immune system? These are all books on and papers on the evolution of the immune system, which Mike had said didn't happen, could not have happened by evolutionary means. And the judge says he simply insisted there was still not sufficient evidence of evolution and that it was not good enough. Now, in fairness, good enough were not Mike's words. Eric said to him, so these aren't good enough. And Mike said, they do not demonstrate that this was done by random mutation and natural selection. Where have you heard that? Is that a good definition of evolution? And it's also very easy because you say, well, no one was there to see it. No one was there to measure it, so you can't prove it. You can't prove an awful lot about your ancestry either, but it doesn't mean we have fights in bars about it. One of the interesting things that came out in the trial is that the Pandas book, on the bottom, sorry, all the way to the right, actually had a history. And one of our former late professor at Berkeley, Tom Jukes, once sent a clipping from the Bible Science newsletter way back in the early 1980s to the NCSE saying, I think you might be interested in this. And it was an ad looking for people to write chapters in biology for a creation biology textbook. That was Creation Biology 1983. It went through various iterations. And we got this information, by the way, by subpoenaing the records. Once we found out that advertisement was, we were like, well, let's go to the publisher. And so we did, and they had all the earliest drafts, and they didn't think fast enough to burn them, so they got a subpoena. And we got them into court, and we just went through the whole thing. What happens if you chart the use of creationism, and chart the use of intelligent designer, you see that at one point, which is at the McLean versus Arkansas trial, where they showed that creation science could not be taught in schools as science, what they did was they took out the word creationism and they put in design instead. And you know how like DNA doesn't always copy exactly, which is how we get some kinds of mutations? At one point we found this. You know, that pesky word processing program just didn't change creationists to design proponents quite well enough. I want a t-shirt with that. So the smoking gun was there. We'd established that the religious creation biology book became Pandas and People. So of course you can't have it in the classroom. These are the three things the judge decided. The first was easy because the school board members had on record that this was a religious purpose. Now, it's fine to believe these things religiously, what you believe, that's not a problem, but to use those as a basis for putting science or changing science in classrooms, that was a problem. The second thing, our lawyers would have been happy with just the first thing, but we said, no, if we don't get the last 2 points, we're doing this again in 6 months. So we really needed them to explain that science is done by the scientific community through peer review. If you don't do this, it's not accepted as science. And there were manifest statements by all scientific organizations to the effect. That was easy, but it had to be put on record. And the third thing, often overlooked but equally important, is that, you know, there are these bogus criticisms that have been refuted for decades. It's about time to get off that horse. You know, we don't need that anymore. It's not hunting anymore. And move on to something else. You're wasting people's time. You're wasting taxpayers' money. You're making kids stupid. And so let's get off doing that. The judge's decision, 146 pages, of which not a single sentence was felicitous to the other side, was immediately excoriated by the same people who thought that John Jones, who'd gone to Dickinson College, had a great liberal arts education, appointed by Bush, friend of Tom Ridge, and thought for sure he was going to vote party lines, do this. Well, he didn't do it because he had a liberal arts education, which you can't ever say enough about. And he said, you know, he pretty much knew when he was being buffaloed. So he got death threats. Federal marshals had to protect him and his family. He did not get death threats from scientists. And it was, you know, and he since has been very active on the lecture circuit talking about the importance of an independent judiciary. You should have him down sometime. He's a great guy. I didn't get to know him until after the trial. So one thing I think to explain to your students, your children, is just because you have a degree in science does not mean you're a scientist. Scientists are people who do research, publish peer-reviewed research as a main part of their living. That's a scientist. A science teacher is the wonderfulest profession, but you're not a scientist unless you're doing this kind of work. A pharmacist has a degree in pharmacology, not a scientist. An engineer, a mathematician, they are not scientists. I'm a paleontologist and evolutionary biologist by trade. Please don't ask me about string theory. Relativity, I know it's like something and then I don't know. I don't know. You know, so I don't like, you know, we all in science are trained in narrow things. compared to all the wealth of what's in nature, and we should be humble about that. So, what's next for ID? Well, the thing about the trial is it pretty much just instantly cut the legs out of intelligent design. There has been nothing about trying to resurrect it as potentially scientific. It just is a non-starter. It doesn't go. But the ID proponents are still, they'd be happy to find another test case. They think the Dover one was a problem, and many of the Discovery Institute experts who were on the team that tried to get the Dover people to accept this realized the Dover School Board was just going way overboard and they could not control them. So they, one by one, dropped out of the case, leaving only Mike Behe. They would be happy to have a better case. Okay, we think we did pretty well in this one, but the judge wrote his decision so that people wouldn't have to do this again. And that's why he tried to do it. So they're encouraging teaching a non-existent controversy, critical thinking, which to them means criticizing ideas you don't agree with, and academic freedom, which means freedom to teach whatever you want, even if it's not in the curriculum, if nobody actually accepts it in a scholarly way. So, this is America, and we have to watch out for this, because we have a lot of people in the country who are very happy with alternative versions of all those things. So, the points, Darwin's definition, another definition that doesn't quite work, random and random, poll questions, founding fathers are mostly deists. In science, we test hypotheses. Intelligent design is not science. And it may just be because I work on big changes in evolution. I think you can talk to people. If you look at your books on evolution, they've got lots of stuff on fruit flies and genetics and stuff like that. I don't think that's going to convince many people who are in that middle 40% that we can explain the major changes in evolution. I've just given you one with those whales, but I could do this all day. I did that for the judge. And it's total fun. I can't think of a more fun, these knowing and working on these problems is just the most exciting thing. It's just so cool. I just love it. And so for me, the trial was like the best thing I did in my professional life because everybody said, well, why aren't these things in the textbooks? Yeah, why aren't they in the textbooks? And until you change your state curriculum to say, these things should be explained, we're going to keep on getting fruit. Fruit flies are wonderful. Genetics is wonderful. Don't let me down. I don't want that bunch of people in my neck, really. They're my colleagues, my department. But, we're not worried about the people who already accept evolution. We're not worried about the fundamentalists. I'm really fine with people believing what they want to believe. It's that 40 or 50% of Americans in the middle who will be convinced by whatever they think makes the most sense to them. But you've got to convince them. You've got to show them the evidence. You've got to show them how we know things. That's what I think this is all about. And the other points, that's about it. So Darwin said it best, I think. He just framed things so beautifully that rather than focusing on divine creation of each thing, he's talking about the things that we have, all the changes that have happened in the world, should have been due to secondary causes. Secondary meaning the laws, the natural laws, that the primary cause, the creator, in his view, set up to make the world run. Without miracles, without intelligent design, without intervention. Let science be science. You guys are great. Thank you for coming.
Thank you for that. We do have time for some questions. I did see a genetics professor in the back. Did you want to say anything about fruit flies? Bob, right here, in front of you. No fruit flies? Okay.
I do have a question, but
I don't think that's on.
now it's on?
No.
Keep going.
Bob. Here we go. Did that do it, Bob?
It's on.
Now it's on.
Okay. I'm not going to defend fruit flies, but I did have a little bit of a question. It has to do with the motivation of the people who are trying to do this. Indiana, in fact, the governor up there is just...
Who are trying to do what?
Trying to pass creation science laws or intelligent design laws in schools and change the curriculum. Indiana is, in fact, in the Congress right now passing one of those bills.
Happens all the time.
And when Judge Overton covered all three of those points in the creation science trial here in Arkansas. But these people aren't going to go away, partly because they're literalists. And therefore, they believe truly that teaching science, as we think of science and evolution in the classroom, is going to destroy their children. And so they are very, very highly motivated. And so how do we deal with that?
I think the same way you do. Those bills come in. It's, politics is local. If these are the local standards, and, many of you live in districts where you know what your local standards are, it's very difficult to get around those things. But once we have legal challenges, once that we're able to clarify what science is and isn't, many of those things fail. It doesn't bother me when bills go through like that because a lot of times they'll fail in committee, they'll fail in votes, but people are playing to the hometown crowd because they have to. And they figure, many of them, that it'll be straightened out in the courts no matter what they believe, if they believe anything at all when they're proposing legislation. So I may be cynical, but we think this is a problem and it takes a lot of time and we really hate replaying the same thing over and over again, but you can't stop people from bringing up things that are important to them. And so, I respect that. I don't agree with it, and I think ultimately if we're going to have good science education in the country, the better we can educate people, the less these things are liable to prevail.
Any other questions? Yes, sir. 1 second.
Okay. Being in NCSE obviously is going to take away from your research time and the things that you want to do professionally. What drew you into NCSE?
We started NCSE. It was a series of what were called committees of correspondence that Stan Weinberg, a biology teacher in Iowa, had begun back in the 1960s, maybe even late 50s. And Stan, in those days, before there was an internet or faxes, he would just mimeograph things and send them around to people in committees of correspondence, just like, where people would pass on information about what some of the leading creationists of the day, like Duane Gish and Henry Morris, were doing, just so we'd understand what their arguments were, so we could say, well, is that good science? And, how do we deal with this? Because, we really, NCSC, we don't take a position on religion. And we get a lot of flack from some of our members who are more hardcore atheists. They want us to do that. We're not going to do that. We're really fine if people understand science and what science is and isn't. We don't want to mess with their personal beliefs. As far as it goes, that's kind of where we stand. We get flack from both sides on this. So we're an equal opportunity offender, I guess. But that's kind of why we did this. And I came from a strong religious background, and I think that a lot of our people didn't. And many of our people who didn't just want things to be explained properly. I'd like kids to learn, the best of what we have out there, not kind of to be confused, so they're going to have to be retaught at a higher level if they ever get there. That's kind of my motivation for doing it.
I remember at the time of the trial reading an article where a science educator was interviewed, and he had what I thought was a remarkable statement. He said of his students, "I don't care if they believe it, I just want them to understand it." Do you think that's a good standard to approach?
I said that myself. Yeah, thank you. Yeah, I mean, I really, when we were doing the science framework in California in the late 1980s, I was one of the people on the committee, one of the people who wrote the framework, and I said, we have to have a statement here that says students don't have to believe what they learn in school, but if they want to be educated, they have to understand it. So, in California, you cannot opt out of something because you don't like it. Like if they're teaching communism, you can't opt out. If they're teaching evolution, you can't opt out. You can only opt out of dissection because they just get tired of kids throwing up. But that's kind of what I think. And we proposed that language in a statement about teaching science. And to my great surprise, it was the fundamentalist Christians who objected to it, because they thought that you should believe what you're taught in school, and that's why they didn't want this taught in school. And I thought, wow, that's okay, fine. But we changed the language, and it's where it is.
Yes, sir.
Bob's going to choose because he's got the mic.
Oh, sorry, Bob. Yep.
Nobody wants it.
Yes, Dr. Padian, I had several family members and quite a number of friends who had hoped to be able to be here this evening to hear you. Given the fact that many were not able to do that, is there some place or source where we could access the materials that you were presenting this evening so that they could look through them themselves?
Thank you for asking. Nikolai and I we did a little talk before, and that's going to be broadcast when?
That interview that we did for back there? Oh, probably in about 2 weeks.
On?
On 89.1, FM 89.1, KUAR.
Listen to it all the time, and it might come up.
Yes, on Thursdays at 6:05.
Okay, Thursdays at 6:30.
We won't be able to show the PowerPoint, but the actual lecture will be broadcast on Clinton School Speakers.com.
And we also, I gave you a little way. If you Google my name with Dover trial slides, you will get the entire testimony with slides. If you are a teacher or anybody, you can download them and you can use them in your classes. We got clearance from everybody to do that, so you can do that if you like. And go to ncse.com. The National Center for Science Education has a YouTube channel with wonderful videos from Jeannie Scott and many of our other people that are just kind of all-purpose, one-stop, should really help you. And again, especially, teachers are paying their classroom expenses out of their own pockets. Us rich university professors can join the NCSC, and I hope you'll all do that.
Right there. Yes. Hold on, 1 second.
Mike's coming.
I probably should keep my mouth shut because I'm definitely, I'm not a biologist, and I'm also not really a particular person of any, particular religious faith or conviction. But there has been this is a layman's kind of question. I have always wondered about the fact that, undifferentiated stem cells seem to be able to just sort of transmogrify themselves into all these other kinds of cells with specific functions that all come together to make up complex organisms. And I had one friend that said he ceased to be an atheist when he looked down in the cradle and saw his son in the cradle for the first time. And I just wondered, this process is, to a layman, it seems miraculous that these stem cells somehow manage to transform themselves, during the gestation process into complex organisms. And again, I'm probably revealing gross ignorance by even
You're
asking
stating this
question,
beautifully. You're using all the right words and stating it beautifully. It is wondrous to us. And Darwin always says in The Origin of Species, every time I see, this complex thing, it's just like he just gets pains in the stomach because, how could something so intricate or seemingly complex ever have come into being step by step? And ontology, your development, is a really amazing thing. Stem cells can do this up to a certain point, then they can't do it anymore. There are many cells in organisms, when they first start, they can become any cell in the body, but then as they start to go to various tissues, they lose that potential to do it. And that's one of the mysteries we have about development, but we're learning. Because, for example, if an amphibian can regenerate a limb, why can't we? And we're learning about the genes that control that and the genes that have been shut off in other organisms that don't let us do that. We have no idea why, yes and no, this happens. But these are some of the really cool things. We can marvel at complexity. We can make it for us a science stopper if we want, but we kind of, think that we can solve a lot of problems eventually. When I was in graduate school, we had no idea about developmental genes. We knew about bristles and eye colors and things like that, but those are structural genes and filters and things like that. But, we would have been down on our knees if we had known then about regulatory genes and what they can do, Hox genes, Pax genes, all these things, sonic hedgehog, all these amazing things that tell us how the limbs form and the body forms in what order. Well, we understand more about the genes. And one of my graduate students figured out how the turtle makes its shell, genetically. where the genes come from to make a turtle shell. I thought that was just like the most incredible thing. But she found the genes that do it. And they weren't the genes that people thought. They weren't the neural crest, for those of you who are wonks on this. They were not from the neural crest cells. They're from the same genes that make the limbs. But the plastron is made from a different system. Wow. That knocks me out. But see, we can find all kinds of cool stuff.
We have time for one more, right in the back. Yep. Yep.
Hi, I'm Chris Keller, and I am a theologian.
Yay!
And my doctoral dissertation is about how Christian faith is compatible with evolutionary science.
About whether Paley is...
No, it's about how Christian faith is compatible indeed with evolutionary science. I certainly think you're right on the science vis-a-vis the intelligent design folks, and it shouldn't be taught as science in school. I wish you would leave the kind of the theological part out of your presentation, because it's flawed and it's misleading in some respects. And but if you decide that you need to keep it, that it's just kind of part of what you need to talk about, one thing you could do that would be helpful, and it might grab a few of the creationists that were there and get them to pay attention, is if you would mention that one of the founders of American fundamentalism, B.B. Warfield, when he first heard about natural selection, he was from a family of cattle breeders. And it made, intuitively, he realized that it made sense, that these processes could have evolved through a natural process. And he said, all that is at stake in this is a theory of the divine providence, that this method is entirely compatible with not only new but traditional Christian theology. And the phrase on that slide, Darwin picked up from Thomas Aquinas, that God works through secondary causes. So either leave the theology out or please add that nuance.
Thanks for your help on this. Most of what I'm doing is relaying the questions and insights that my own students have. And I have a question for you, which did B.B. write this before or after the Great Awakening?
B.B. Warfield wrote in the latter part of the 19th century. He had read Origin of the Species.
Okay, so before the Great Awakening. Okay.
Well, the Great Awakening was with Jonathan Edwards. That was 100 years before.
But I mean, what do they call the one in the early 1920s, the kind of rise of fundamentalism again?
I don't know. Neither you nor I as a historian.
Okay. Thanks for your comments. That's very helpful.
Well, thank you all for coming out tonight. Anna, thank you for thinking of the school, and we hope to see you all again at a future program.
Thank you.